Oh, hi friends, this is Vivek Babele again, and today we will discuss about cutting tool in machining. First, we will discuss about cutting tool classification, in which there are two types mainly. Number one is single point cutting tools, in which there is one cutting edge. Turning uses single point tools. Point is usually rounded to form nose radius. Multiple cutting edge tools or multi-point cutting tools in which there is more than one cutting edge motion relative to work usually achieved by rotating. Drilling and milling use rotating multiple cutting edge tools. So this is the basic classification of cutting edge tools, in which first is the single point cutting tool and second is the multi-point cutting tool. These are the diagrams for milling cutters. Now we move on to the cutting tool characteristics. And there are various characteristics which should be there in a cutting tool. And there is hardness at elevated temperatures, strength, wear resistance, permanent indentation resistance. Then toughness, because repeated operations by retaining shape, no breakage or chipping off. Then wear resistance, which increase to life, chemical stability or inertness, workpiece or coolant. Now we discuss about cutting tool materials. Carbon and medium alloy steels, easily shaped and reshaped, no high hot hardness. Drill bits, tabs, broaches, reamers are used made by this carbon and medium alloy steel. Then high speed steel, which is used in high speed cutting, high toughness, resistance to fracture. Tungsten and molybdenum tools. Continuation in cutting tool materials with cast cobalt steels, which had good wear resistance or hardness. Carbide inserts, which is tungsten and titanium carbides, very high hardness, very high resistance. These are metal cutting operations. In the orthogonal and oblique, two types of cutting is there. Again, side view for the metal cutting operations. This is heat generation during the metal cutting process. Now cutting conditions. So the relative motion between the tool and work, the primary motion cutting speed, the tool move laterally across the work, slower motion feed, penetration of the cutting tool below original work surfaces, depth of cut. Collectively, speed, feed and depth of cut are called the cutting conditions. These three words are most important: speed, feed and depth of cut. For certain operations, their product can be used to obtain the material removal rate for the process, and this is the mathematical. Tool orientation depends on the operations performed: straight turning, shoulder turning, facing, chamfering, forming, parting off. These are the types of lathe tools, different types. Classification of lathe machine depends on the maximum diameter of workpiece machined or swing, maximum distance between headstock and tailstock, and length of the bed. The components of lathe machines are headstock, in which spindle and speed change lever is there, tailstock, in which spindle and lock bolt is there, then carriage, on which the tool post is mounted, top slide, taper attachment, compound rest, cross slide, apron, lead screw, etc., bed and legs. Tools of lathe machine: left hand side tool, facing turning and taper turning; right hand side tool, outside threading tool, external threads, boring tool; internal facing, increasing hole and smoothing; left side threading tool, parting tool, separating workpiece from other material; learning tool, hard workpiece is pressed with it; revolving tool, supports workpiece; drill chuck to move the hole. Speeds of turning operation on lathe is of this order. For aluminum alloys it is 200 to 1000 rpm. For cast iron, it is 60 to 90 rpm. For copper alloy, it is 50 to 700 rpm. For steel, it is 50 to 500. Stainless steel, it is 50 to 300. And for titanium alloy, it is 10 to 100 rpm. Accessories of lathe is gearbox, head screw, feeder rod, clutch, tool and pump is used in there. 3-jaw and 4-jaw chuck, which is used to hold the workpiece. Faceplate, driving plate, fixture, traveling steady, dead center, revolving center. This is a lathe machine with all its parts showing. Different parts of lathe machine. This is center lathe, this is heavy duty lathe, tool room lathe, bench lathe. Now CNC lathe. CNC lathe is computer numerical control machines are being used in every concept manufacturing process nowadays. And a CNC machine functions like program, storage, tool offset and tool compensation, program editing capability, various degree of computations, and the ability to send and receive data from a variety of sources, including remote locations, can be easily realized through on-board computer. The computer can store multiple part programs, recalling them as needed for different parts. This is a CNC lathe, floor type boring machine, single column vertical boring machine, double column boring machine, shaper machine, double column planing machine, single column open side planer, shaping machine, bench drill, which is very common. You can see it in every workshop almost. Hand feed drill machine, power feed column drilling machine, radial drilling machine, multi spindle drilling machine, turret drill head, types of drill points, multi spindle drilling machine, radial arm drilling machine, horizontal milling machine, vertical milling machine, horizontal spindle reciprocating table surface grinder, single spindle automatic screw machine. Few more precautions for these machines are: machines should be operated by authorized person. Check up for elect connections and lubricant before working on machine. Don't wear watch and ring during work. Very important precaution. Wear leather apron and boots. Machines of safety: never work alone. At least 2 workers must be in the shop when power tools are being used, just to avoid any type of accident. And if the accident happens, then one should be there to help other. Never work when you are impaired. This includes when you are too tired, stressed or hurried to work carefully. Safe conduct in the machine shop. Your conduct in the workshop should be safe and responsible and not hurtful or damaging to any worker, operator. Concentrate on what you are doing, and if you are start getting tired, please stop and take a small break. Never try to rush tasks. Machines of safety continuation: always wear closed toe shoes in the shop. Never wear sandals or chappals or anything like that in which your foot is open. The tools, chips, and fixtures are sharp and often hot. Shoes will help protect your feet from injury. Leather shoes are preferred when machining. Eye protection is very essential. So always wear safety glasses when working or cleaning tools. Remove or secure anything that might get caught in moving machinery, like rings, necklaces, wristwatches, long hair, and loose cloths that get caught in tools and can drag you along. Now keep your hands away from sharp tools, which is make sure that nothing that you do will cause you to be cut. Use safety gloves to handle hot or sharp objects. Dust, chemicals, and smoke can be dangerous. Work in well ventilated areas. Minimize contamination and use appropriate protective equipment. Ask for guidance and help. Shop staff check you out on a tool in the first time you use one with which you are unfamiliar. Be careful while working. If you do not know how to do something, ask before starting. Study the machine and know which parts are moving, which are stationary, and which are sharp and may be potentially dangerous. Listen to the machine and never leave the machine running unattended. Clean up after yourself. Before you leave the shop, all tools must be returned to the